This video will review the solutions to problems 15 and 17 from Chapter 2. The subject of these problems is probability. Problem 215 states that a silver dollar is flipped twice, and we need to calculate several probabilities that could occur within these two flips. Part A asks, what's the probability that we get a head on the first flip? And if it's a fair coin, there's a 50% chance of getting a head on the first flip. Part B asks, what is the probability of getting a tail on the second flip given that the first toss was a head? The notation on the screen, the P stands for probability, and then we would read this notation, the probability of tails given a head. So the vertical line is read as given. So the probability of a tail on the second flip given a head on the first flip. The thing we have to understand here about flipping coins is that the head on the first flip has no effect on the second flip, so this is still just 50%. No matter what happened on the first flip, the probability of getting a tail on the second flip is 50%. Part C, what is the probability of getting two tails? So we want the probability of getting a tail on the first flip and a tail on the second flip. In this case, we can use the multiplication rule of probability for independent events. We know that these two events are independent. The tail on the first flip has no effect on what is flipped on the second flip, so we would simply multiply the probability of a tail on the first flip times the probability of a tail on the second flip. If we go ahead and make this calculation, we'll see that it's 25%. Part D, what is the probability of a tail on the first and a head on the second? So a tail on the first and a head on the second. Again, we use the fact that these two events are independent, and we would use the multiplication rule for independent events. The probability of a tail on the first flip is 50%. The probability of a tail on the second flip is 50%. And so if we multiply these two probabilities together, we get the probability of these two events occurring together. Part E, what is the probability of a tail on the first and a head on the second, or a head on the first and a tail on the second? So we want the probability of getting a tail on the first flip and a head on the second, or probability of a head on the first and a tail on the second. In this case, we already have one of the probabilities calculated here. And so we would use the addition rule here for independent events. We have two events, so the probability of a tail on the first and a head on the second we know is 0.25. We just calculated that, and we can see that the probability of a head on the first and a tail on the second would just mirror that probability. Now we know by inspection that these two events cannot happen together. We are either going to get a tail on the first or a head on the first. So the two events listed on lines 8 and 9 cannot occur together So we can simply use the addition rule to calculate the probability that one or the other of these two events occur. And that would be 50%. What is the probability of at least one head on the two flips? Here it might just help to list out the possible outcomes that we can get when we flip a coin twice. We can get a head on both flips. We can get a tail, a head and then a tail. We can get a tail and then a head. We can get a tail and then a tail. And if we look at some of our other calculations, we can see that the probability for each of these outcomes is 25%. Three of these outcomes include at least one head as part of the outcome. So we would simply sum up the probabilities of the three outcomes that include at least one head. Again, none of the four outcomes here listed can occur at the same time, so we're using the addition rule to calculate this probability, and it's 75%. Now let's look at problem 17. Problem 17 discusses a case where a certain number of 5 types of nails are placed into a bin on a given day. The numbers of nails are listed here on the screen and are given in problem 17. We can see that there are 1,719 total nails. In fact, this is calculated as the sum of the observation of each of the 5 sizes. We are using the relative frequency method to come up with a probability distribution for the various sizes of nails. This is also called in the textbook objective probability. To come up with the probability, we simply divide the number of each size by the total number of nails. When I enter this in Excel, I'm going to put an absolute reference or a $ sign in front of the row 8 so that I can simply copy this formula down and calculate the probability for each size of the nails. I'll copy it down by dragging this corner down to the row representing 5 inches. And we can check to make sure that the sum of all these probabilities equals 1. Now we're asked some questions. Part A, what's the probability of reaching into the bin and getting a 4-inch nail? We can see via the relative frequency method, we would estimate this probability at about 26.2%. Part B, the probability of getting a 5-inch nail, is about 19.4%. In Part C, it asks if a particular application requires a nail that's 3 inches or shorter, what's the probability of reaching into the bin and getting a nail that satisfies those requirements? There's 2 ways to calculate this. We want the probability of getting a 3-inch or shorter nail. Of course, this is the probability of a 1-inch nail, plus the probability of a 2-inch nail, plus the probability of a 3-inch nail. So if we add up these 3 probabilities, we should get the correct answer. It's about 54.4%. Of course, the other way to calculate this probability is to take 1 and subtract the probability of a 4-inch nail and the probability of a 5-inch nail. because those are the two outcomes that don't fit our criteria. If we do that, we should replicate the previous answer. In either case, we get 54.4%.